So global challenges for business and society, that's what we've been talking about. We are in week 5, time's probably moving a bit slower, but that's fine. Next week, next week's lecture, I want to dedicate it to a full workshop on coursework 1. Okay, so what I want you to do is next week when you come here, you bring your laptops with you, sit in the groups that you've been assigned to in your seminars, and we'll start tackling coursework 1. So we'll go through question 1, we'll break it down into introduction, main body, conclusion, and then we'll talk about question 2, how to tackle that. Then we'll talk about question 3. So we start talking about coursework 1 in lecture 6 next week, lecture week number 6. And then in week 7 seminars, that will also be run by the seminar tutors as your um, uh, as an assignment workshop. So we want to start writing that so that you are ready with the assignment as a group by the time you finish. It's 13th of November. I think that's when your deadline is. I might probably extend that by a few days, maybe make it from Wednesday to Friday or a Monday next week or something, so that that gives you enough time to kind of mop up everything. But remember, bring your laptops with you. Next week in the classroom, it'll not be a recorded session. It'll be run as a workshop, so you can start writing your workshops. Does everybody know that you're part of a small working group in the seminars? You're all clear about that? Anybody who's not part of the seminar groups? Okay, you're not. Okay, you're not sure about it. Which seminar are you in? Oh, you have one today. So maybe your seminar tutor will divide you into groups today, right? So your coursework 1 is a group assignment. Remember, it's a team assignment, and most students have been assigned to a team in the classroom, probably a team of 4 or 5, and you'll be writing the first assignment as a group. So not everybody has to submit it. You write it as a group, and you nominate one member of your group to submit that assignment. Okay, so make sure who that person is. Always have a backup. So in case something happens, the laptop of that person breaks down, internet connection is not there, you can at least tell them on the WhatsApp chat saying that, my laptop's not working, I'm not able to upload it. Can somebody else do it? So always have a backup so that you're not late in submitting. If there is any difficulty, any problem, straight away send an email to me. Okay. So next week will be our coursework 1 workshop. I will run a similar coursework 2 workshop probably in week 10 or something, so that you have enough time to write that as well. And we'll start tackling that. So remember, next week is a workshop for your assignment for coursework 1. Right. Okay. So we are now kind of coming to the end of our carbon literacy training. This is week number 5. So we started this in week number 2 in the lectures, and of course, weeks 3, 4, 5, 6 in the seminars. We've talked about already the science behind climate change. What is it? What is global warming? What is the impact of rising temperatures? But we also looked at the whole problem from a different lens. We don't just want to understand climate change from a scientific perspective. We don't only want to understand climate change from an environmental perspective. We want to understand climate change from a social, political, human rights lens as well. And we then established that climate change does not impact people in different parts of the world, in different generations, people from different communities in the same way. It affects people in many different ways. And we took examples in the classroom as well. For example, somebody living in a remote part in Africa or Asia, the countries that are smaller and they haven't really contributed so much, mainly in the developing world, haven't really contributed so much to climate change. But they are the ones who are most affected. They're the ones who are most vulnerable to climate change. Why is that? Even though the developed countries have contributed a lot more over a period of time to climate change, we know that they also have the means and the capacity and the capability to fight against climate change. So, for example, if there is a storm, Storm Milton, for example, happened 2 weeks ago in the US, we know that the government had the capacity to evacuate people, create flood defenses, provide compensation to people who are actually affected if they lost property, if they lost land, if they lost crops, harvest, etc. They're being given the compensation. So the loss of life, even though sadly there was some, it was limited. Imagine if the same thing happened in Bangladesh, same intensity of storm, let's say, and that's actually happening right now. It's called Dana or something, Storm Dana. If the same thing happened in Bangladesh or a country which is not so much contributing to climate change, a developing country, there'll be a lot more loss of life. Hundreds and thousands of people would have died. Um, Property loss would have been more and not compensated by the government because the government doesn't have the capacity. There would be no infrastructure to support people in that regard. However, if you look at Bangladesh, have they contributed the same as the US in terms of climate change? They haven't, because US is a much more industrial developed country, whereas Bangladesh is not so much of a developed country. It's a developing country, one of the poorer countries. And so therefore, the disproportionate impact of climate change needs to be understood. And we did that when we tried to understand climate justice. We then moved on to create scenarios. We also learned about Paris Agreement. And if you go back to your reading material on GCE Learn, you'll find that Paris Agreement, there's a link I provided there to you. In the Paris Agreement, they very clearly agreed that we must do everything that we can to limit the global temperatures to below. You remember anyone? Below what degrees? That's also one of the quiz questions, by the way. 2 degrees, thank you. And do everything which is possible to keep the efforts to keep it below what? Sorry? 1.5 degrees. Thank you. So remember those two figures, 2 degrees and 1.5 degrees. That's one of your quiz questions as well. And I'll revise some of the questions today in the slides. Right. So we, on the basis of the Paris Agreement, that we must do everything we can to keep a global temperatures below 2 degrees average rise, and do everything that we can to keep them below 1.5 degrees by 2050 if it's possible. Okay. There are two scenarios then. Either we go over the 2 degrees global temperature rise, or we keep below the 2 degrees global temperature rise. If we carry on doing what we're doing right now, business as usual, and we looked at those scenarios in the seminars, we will definitely go beyond the 2 degrees. And there is also estimates that we might actually go up to 3 to 4 degrees. In fact, if you look at, I'll put this up on GC Learn as well later on. But if you actually go and look at the emissions gap report 2024, this one actually tells us, you can download the full report really. It tells us where are we with regards to our tracking of tracking of global temperatures. That didn't work. Yeah. Right. So you can actually go and read this report, and this tells us where are we in terms of what we've promised different countries. You can see here, no more hot air, please. That's the UN's report they publish every year. With a massive gap between rhetoric and reality, countries draft new climate commitments. Next month is the COP, the communication of parties that happens every year. And this report is published yesterday from the UN. I will upload this report under reading material so you can actually have a go. It's really important. So there is a massive gap between what countries have promised to do and what they're actually doing. If the gap remains or increases, we know that the temperature rise will go beyond the 2 degrees, and they're estimating to about 3 to 4 degrees, and that would be devastating. What they want countries to do is when you promise something in terms of providing compensation, in terms of changing the ways in which you're burning fossil fuels, in terms of investing more in technologies that will help to capture carbon from the atmosphere, then that'll help us to close that gap. So one of the things that we'll do today is we'll try and understand how those scenarios can be regulated when it comes to supporting climate change. So that's really very important. So we will be talking about solutions. We are already talking about solutions in this week. So for those who've already had the seminars, we're talking about the individual carbon footprint control. So you're calculating your travel-based carbon footprint today. I'll be creating similar guides for food and energy as well. And for those of you who got seminars today, you will actually do this exercise in the class today to calculate what's your individual carbon footprint with related travel, and then you'll be able to reduce that carbon footprint later on as well. So we've started to do the individual strategies, but we'll also start looking at group strategies today. And we want to divide those groups into two parts. One is the group that actually is closer to you, the group that you interact with on a regular day-to-day basis. And that could be your friends, your family, your community, the students that you meet, everybody that you kind of can influence directly. Okay, the people that you meet on a regular basis. But the group strategies could actually be defined in other ways as well. For example, what does a society needs to do? What does the government wants to do? What can be done about these things? And that's linked to your question number one of your coursework one. So it's really important that we start understanding those things as well. And we will use a simulator today. All of you can do that. It can only be used on a laptop, for example, or a desktop. It can't be used on the phone, but that's okay because we'll be doing that, or you'll be doing that in the seminars next week. But I'll be showing you a little demo of that today. So we are now moving towards the end of it, which is trying to find out solutions to climate change. So you got three objectives of this week, broadly speaking, which is making a commitment to change as an individual. So if you have done the exercise, or if you will do the exercise today, if you got seminars today, of understanding what's your individual carbon footprint, and then trying to make a change, create a pledge that I will change my behavior about travel or food or energy consumption, etc. Make a commitment to work with others in a joint endeavor to reduce greenhouse gas emissions. What can you do with regards to your sphere of influence, the people who you can influence? Can you make a commitment to that? And finally, we'll look at what can be done at a broader level, which is the policy or the regulations level, can help to limit the average rise in global temperatures to below 2 degrees, and that's our target. So today's we got four parts, broadly speaking, but we'll continue with the final part in the next week, because next week is the coursework one workshop, as I mentioned. So we want to consolidate knowledge. There'll be some questions coming up. These slides are already up there on GC Learn. Very useful in terms of your course, not coursework one, the quiz, the first part of the quiz, the 10 questions. If you remember, in the last 2 weeks, I'd already started talking to you about what kind of quiz questions will come up. So I'm hoping that you're making notes. If you haven't, you can always go back to the video recordings of the lectures from previous weeks. I've always mentioned after every now and then what kind of questions might be useful. So I think we have discussed about 4 or 5 questions already, and there'll be a few more today. So I'm creating a questions bank of maybe about 30, 40, 50 questions, and then you will get at random any 10 questions from that. Okay, so it could be different questions for different students, but we'll talk about that next week and in the succeeding weeks after that. We want to also understand our spheres of influence, people who we can influence, and how do you communicate climate change? What is it that you need to um, keep in mind when you're talking to other people about climate change as well? So that's what we want to do. But the first thing that I really want to, I mean, this is a running theme as a basis of what we're learning, is that it's urgent now. Urgent action is required to negate the effects of climate change, to limit the global rise in temperatures, because that may have quite a devastating effect. So let's recap a little bit. I know the answer is there on your slides, but if you can kind of not look at them for a few minutes, that'll be quite helpful. So we have discussed about this before. So scientific consensus. What proportion of climate scientists do you think support the consensus opinion that human activities are causing climate change? Any ideas? How many kind of scientists are telling us? Say again? 97. Thank you. That's correct. So the answer is D. It's 97%. Overwhelmingly, scientists have actually been talking to us about this for years now, to say that the climate change is real. It's caused by human activity, and more than 97% of scientists believe that that's true. However, is that not enough for us to be convinced that climate change is real? What more do we need? And I think it's really important that we understand it, that if so many scientists are saying, and IPCC, remember that's one of the questions I will ask, what does IPCC stand for? It stands for Intergovernmental Panel on Climate Change. I don't know whether that's question number 5 or 6 that we're talking about, but that's one of the quiz questions also. Okay, remember that word? Have you heard that word before? I'm sure we have in the classroom now. Do you recall, everybody? Anthropogenic climate change. What does that mean? Climate change caused by what activity? Human activity. Thank you. That's correct. So that will be one of the quiz questions as well. What causes climate change? What is anthropogenic climate change? And that's something that's caused by human beings. Now, these graphs don't have any specific meaning that I wanted to portray, but all I wanted to say was there are hundreds and hundreds of tests and experiments going on to measure the impact of climate change. And IPCC is a group of scientists globally whose only job is to measure the impact of climate change on a regular basis. They've been doing that for years. And more than 97% of those scientists have mentioned that climate change is real and it's caused by human activity. Now, one of my professors actually used to mention this quite regularly, that what is the reason why we can't believe when scientists tell us that 97% of those scientists are telling us that it's real and it's caused by human activity. And he used to give me an example saying that you're driving on a bridge and 97% of experts, structural engineers say that this bridge is going to collapse. And 3% say not to worry. Who would you believe more? It's a very simple question, isn't it? I mean, this one, we won't have any options in the sense that we don't have an alternative thinking here. We're not really saying that, no, I think the 97% are really not correct. I'll go with the 3% and I'll actually drive over the bridge. Most of us will not do that. Okay. And why is that? Because we know that we want to listen to the experts. When there is an expert who says, and let's say you're driving over the bridge and there's a board before you come on the bridge, which says this bridge might collapse. 97% of engineers think so. You probably wouldn't go on that bridge because you know that it might collapse. And that's where we are standing with climate change. If 97% of our scientists who've been working on this for years and years are telling us that climate change is real and it's caused by human activity, I think we better believe that. That's the main point here. So 97% of climate scientists agree man-made climate change is real. So it's time to listen to those people. So yeah, that's right. The answer was more than 95% of climate scientists have an opinion that human activities are causing climate change. So what is the story so far? So far, we have experienced around how much of global warming? Yeah, I heard the right answer. 1.1 degrees. Thank you. That's correct. So we're not there yet. Okay. So what scientists are saying is any rise in global temperatures is devastating. Any rise, a 0.1% rise. For hundreds and hundreds of years and thousands of years, the temperature of the Earth has remained stable. There has been no rise. Okay. But since industrialization, since we started to burn fossil fuels, burn coal, burn oil, and increase the particles of carbon dioxide in the atmosphere, the temperature of our Earth has started to increase. And even a slight increase, it might feel that 1.1 or 1.5 or 2 is not so much. But even a slight increase of 0.1, 0.2 changes the balance of temperature on the planet. And that's where the difficulty is. Every single point rise in temperature is causing the weather systems to change, the crop yields to move away from where they normally are, people to move away. It'll be very difficult already in some countries to work outdoors or be outdoors. Okay. It'll be even more difficult. Imagine as human race, we're not able to go out of the house or our offices. We're always covered and protected. And that's because there's so much heat out there. And even a slight rise of temperature actually is causing that. We've already reached, as you said, 1.1 degrees. That might be one of the quiz questions. We've already got to that point of 1.1 degrees. And where we might end up, that's going to be quite difficult. So many of these tests have shown us that since the late 1800s, it has been quite stable for quite some time. But see this point here, this is where it starts to rise. And what happened at this point here? Anyone? Human beings did something here at this point here. What was that? Industrialization. We discovered oil, we started to burn coal, we started mass factories, mass production, assembly lines. All those things happened around this time. And suddenly then, no surprises, the temperatures started to rise sharply. They call it a hockey stick curve. You know, hockey sticks are that straight and then up. That up is happening now. So we are already sitting at 1.1 degrees. These are all the different, kind of experiments that are going on for years and years. And they've been measuring the global rise in temperatures, and they're directly related to the amount of carbon particles existing in the atmosphere. Now, these carbon particles used to be around 200, 210, and that's okay. That's a natural figure that we need to understand. But that has now doubled. That's gone up to 435 parts per million in the atmosphere. And that double amount of carbon dioxide is trapping more heat from the sun. And that's what is warming up our planet. And that's leading to quite a difficult scenario at the moment. So the story so far is that we got 1.1 degrees. But where do we want to get to? What are the safe limits? Now, anything over 0 degrees, average rise in temperature, is not safe. It's changing our climate. But in the Paris Agreement in 2015, all the countries that actually signed up to it aimed to keep the rise in global temperatures well below X and to pursue efforts to limit it to. That's an answer I think you all should know. We have talked about this many, 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 many times over the last 4 or 5 weeks. What are the two figures? 2 and 1.5. That's correct. So the correct answer is B, that all countries are saying that by the end of the century, we must try and limit the global rise of average temperature to below 2 degrees and pursue all our efforts to keep it below even 1.5 degrees. And then over the next century, bring it to 0 if you're able to. And that is possible because we have made advancement. We know what to do. We know what the problem is. And we are making a lot of efforts to change that. So we are pretty much on track. I'm not on track. I shouldn't be so hopeful. We know what to do, but countries have to start taking that action in terms of regulations, in terms of policies, in terms of changing the way we live, etc., and that sort of thing. And we have to as individuals as well. We can't ignore the fact that we have a big role to play. Now, you might say that I'm just an individual. What can I do? If I stop driving and take the bus, would that make any difference? Very minute, very small, but collectively as a whole, if all of us start doing things, then that might make definitely a huge difference. So it's really important that we start thinking about in that ways. Okay. So yes, that's correct. One of the quiz questions again, 2 and 1.5. Remember those numbers, and that'll be quite useful. Don't be confused by other ones, please. The correct answer would be 2 and 1.5. And remember, it might not be B always. It might be C or D or whatever. So, but remember those two figures. We need to keep it below 2 and do all our efforts to keep it below 1.5 degrees. But what is the impact? If we do go beyond 2 degrees, what will happen? You can see here that there's a scale of the impact or risk: undetectable, moderate, high, or very high. And that's the rise in temperature. So we are sitting at 1.1 degrees here. We are sitting right now here. Okay. And you can see the impact of each of those. Even a slight rise of 0.25 average global rise of temperature, that might have happened decades ago, coral reefs will start having an impact. Okay. There's something called as bleaching of coral reefs. And you might have seen many, many parts around the world, and I've seen it myself, that you will see that those colorful reefs in shallow waters in many parts of the world, they turn white. They're dead. Okay. And they part such an important part of the ecology of the ocean. They're so sensitive to the rising temperatures of the ocean that even a 0.25 rise starts having a moderate effect. Imagine what's happening at 1.1. A huge percentage of coral reefs around the world have already bleached because of the rising temperatures. So the effect is there already. Arctic region, the ice caps, they start to melt, and they're already melting at 1.1 degrees. Okay, we can see that the impact is moderate to high. Coastal flooding, now because of Arctic ice melt, the level of water in the sea rises, okay? And that leads to flooding in coastal areas where people live near the coast. They're already affected by that, okay? Imagine what's happening at 1.1 degrees. Flooding in rivers, that's also happening because of change in weather, okay? Increased flooding. Every year you will see, I don't know whether you've heard this before or not, but our summers are getting wetter and wetter, and our winters are getting warmer and warmer. And that's a phenomenon we've been observing for years now in the UK in particular, right? So river flooding is a new phenomena, and that's becoming more frequent. Um, Heat-related disease and death, that's happening a lot at the moderate or high level now. Heat strokes, etc., is becoming very common, and crop yields. So the productivity of crops, how much can each crop give us, is changing as well because of the changing weather, and that's going to have an impact on the food security and the amount of food that we may grow around the world. So that might be a bit of a challenge there. But that's happening all at 1.1 I'm talking about. Imagine if the temperature goes up to 2.5 degrees, no coral reefs left, Arctic ice completely gone, coastal flooding high, river flooding high, in fact, very high. Heat-related disease and death increases quite significantly, and crop yields are affected badly, very highly, which means that every area that we are talking about is having an impact if those temperatures go beyond 2 degrees. So we must really do everything we can to be able to keep those temperatures down below 2 degrees. Oops, okay, sorry. I gave you the answer already. So the United Nations then tell us that to have a reasonable chance of achieving Paris Agreement targets, global emissions would need to reach net zero by what year? 2050, right? So it's important that that year is kept in mind, even though we are saying that these temperatures are estimated to rise by the end of the century, 2100 really. So we got 75 years. But when they're setting targets, the United Nations is saying that let's work towards 2050. If the whole world can become net zero by 2050, then we have a chance of keeping the temperatures below 2 degrees by the end of the century. Because these things take time, it's a slow process. So it really takes time to do that. So 2050, remember that also as one of the quiz questions, possibly. But what is net zero? We've been talking about this word. So we've talked about three main words. We've talked about carbon neutrality, we've talked about net zero, and we've talked about zero carbon. They all more or less mean the same things. The difference is when they started talking about this, they used the term carbon neutrality more than other words. And what carbon neutrality meant was that you can keep emitting your emissions as much as you want, as long as you start investing in technology that will help to capture that carbon emissions out. But there was no incentive as such for governments and industry to reduce their carbon emissions. And that's when we started to talk about a term called net zero. Net zero also means the same thing, that you capture or absorb the amount of carbon that you emit. But there was now new incentive to say, try and reduce your emissions as much as you can. How can you do that? Change your electricity from fossil fuel based to renewable based. Change the way you eat. If you're importing your food from outside, try and buy local so that you reduce your emissions, and many different things. Okay, small changes in behavior, small changes in the way organizations operate, etc., and that sort of thing. And that was what net zero and zero carbon means, that we reduce our emissions to such a low level that whatever is left can be absorbed out. How do you absorb carbon dioxide from the atmosphere? Yeah, through trees and plants. That's correct. So trees are the natural carbon absorption devices. We got plenty of them, but we're cutting them down. So if we stop deforestation, or if we reduce the rate of deforestation and we increase the rate of afforestation, we increase our capacity to absorb that carbon dioxide, the extra carbon dioxide from the atmosphere. At the same time, we start investing in carbon capture technology. So there are artificial means of absorbing carbon from that atmosphere as well. So that's also possible. So we need to do all we can to reduce our emissions to as low a level as possible, and then whatever is left can be captured out, absorbed out by the trees and artificial means. So it's really important that we understand what net zero is. So this is a United Nations definition, which says, put simply, Net zero means cutting carbon emissions to a small amount of residual emissions that can be absorbed and durably stored by nature and other carbon dioxide removal measures, leaving zero carbon dioxide particles in the atmosphere. I wouldn't really mind if you started your coursework question one with that definition, okay? Or similar other definitions if you wanted to. That demonstrates to me that you have a knowledge of the context in which you're talking about. So it'll be a good start to your coursework question one to start with the definition like that, okay, of net zero or zero carbon or carbon neutral, what that means. So you can always do that. This definition is taken from United Nations, and you can find that on this link here. Okay, so please feel free to copy and paste if you wanted to. However, what we're doing right now is not enough. Those two graphs or those two figures tell us that. So increase in global greenhouse gas emissions projected by 2030. So we are still on the rise. We haven't really started to reduce them yet. We're still on the rise. There'll be a 9% increase in the next 6 years compared to 2010 based on available national action plans around the world. Okay? What we need really is a 45% reduction, not a 9% rise. We need to bring it below that level if we want to keep the global rise of temperatures to below 1.5 degrees by 2050. Okay, we don't need that. We need more of that. We need to reduce our reliance, and countries have to start making plans to that. I've mentioned this a couple of times before, and I'll probably also find a news article related to that, put that under our reading material in GC Learn. But the UK government, just about 2 or 3 weeks ago, took a very firm decision that none of our electricity in the UK will now be produced by burning coal. It's a very clear policy. So in the UK now, there is no reliance on coal for burning coal to produce electricity. And that's a big policy decision. We need more decisions like that by the government to invest more in carbon capture technology, to invest more in public transport, to invest more in the infrastructure for electric cars charging, etc., electrification of our buses, using hydrogen for our buses. All these things will actually reduce our carbon emissions significantly and hopefully reduce it by 45% or more so that our global temperature goes below 1.5 degrees. It's really important. And we also know at the same time that most of our emissions are coming from just a few countries. So we've seen the climate justice one when we were doing that quiz in the classroom. We were looking at what countries emit more and which countries are affected more as well. Okay, and that's coming from this link here, emissions gap report, the one that I was showing you a little while ago. The top 5 emitters are China, US, India, the European Union, and the Russian Federation, which accounted for about 60%. So 5 countries in the world amount for 60% of all emissions. And all the rest of the world combined amounts for only 40%. So there's a huge skewing there. The group of 20, the G20, Argentina, Australia, Brazil, Canada, China, France, Germany, India, Indonesia, Italy, Japan, Korea, Mexico, Russia, Saudi Arabia, South Africa, Turkey, the UK, the US, and the European Union, the top 20 global economies, are responsible for about 76% of global greenhouse gas emissions. 76%, just 20 countries. By contrast, least developed countries account for about 3.8% of global emissions only, while small island developing states contribute less than 1%. So you can imagine that this is disproportionate. It's not that all of us are contributing equally. Larger developed countries are contributing a lot more. And so therefore, the argument goes that these countries must actually do more to mitigate the impact of climate change. They must not just continue or carry on doing what they're doing. They have to change something. Now, this is something very useful, and I would really encourage you to do. There is a free course from the United Nations. You can provide the link there. All you have to do is to register, and you can do this course freely. And there are a number of modules. They're all online. You take a quiz at the end, and you can be a net zero certified person. So you can actually get this certificate from that. Do the course, take the quiz, get the certificate. Okay, it's free, and it's available to everybody. So if you want to enhance that, your CV, you will get the certificate from GCU as well, the carbon literate certificate. And why don't you always also go on and get the certificate from United Nations as well? That'll really help you quite a lot. Now, over the next 4 years, I would really encourage you to start looking at what kind of jobs are available out there. We have students who've actually gone on and done internships with the UN in the past. We've had students who've actually, you've heard from one of them, Manon Forrester, who works with the organization called BITC now, Business in the Community. I have put the recording up under guest lecture folder, and there'll be another guest lecture coming in the next couple of weeks. I have invited the sustainability officer of GCU to come and speak to us about what GCU is doing in terms of reaching its net zero targets. Okay, so hopefully they'll come next week. They'll speak for about half an hour or so, and then we'll do the workshop. So these are opportunities available to you to be able to enhance your knowledge, get certified, improve your CV, so that when you go out there to find a job, you'll have a better option there to get that job, hopefully, right? So everything about net zero is up there, but not just about net zero. You've got other courses as well that you can do. So please make sure that you kind of think about that. Right. So this might be slightly something that you might not have thought about yet, but thinking about more local, so that 2050 target is what the United Nations has set for us. Okay. But that doesn't mean that everybody must, reach net zero by that time. People can actually say we'll reach net zero by 2045 or 2040 or something else. Do you know what's the Glasgow City Council's target? A 2030, that's correct. Yeah, absolutely. Yes. So that was declared in 2019, and they gave themselves a time of 11 years. But yes, you're right. A lot of people think that it's probably too ambitious. But Glasgow City Council was one of the only councils in the whole of the UK who actually set that high ambitious target. And you will see that when you start working backwards from that target of 2030, you will see that there will be a lot of changes that probably are already made within the city. I mean, you might have seen electric buses, and you might have seen congestion zones or low emission zones, etc. Housing changes, uh, trying to make houses more energy efficient so that there is more heat trapped inside, more insulation, etc., etc. So all those technologies are developing and changing. Why is that? Because Glasgow as a city area wants to be a net zero region by 2030. Now, this is a very ambitious target. Whether or not they'll reach there by 2030 or not, we don't know, but definitely soon after they might reach, which is still a very positive thing. So Glasgow as a city will become a net zero city by hopefully 2030 or very soon after that. Okay. So yeah, that's correct. The answer was A, 2030. What we need to move on to now is to understand what can we do, very small one, and then I'll give you a demo and then we'll leave. So we might not take the break, we might finish early. So spheres of influence, what are those? Spheres of influence very clearly are those people who you can influence easily. Who can you influence easily? People with whom you interact more regularly. Who do you interact more regularly? Your friends, your family, people you live with, your flatmates maybe, uh, people you work with. You might be doing a part-time job, and there might be 5 or 10 people, 15 people that you're working with on a regular basis. You interact with them, you can influence them. Maybe a community that you're part of in your neighborhood, for example. It could be a church community or any other religious community. It could be a book reading club that you might be part of. It could be anything. It could be a group of students that you interact with on a regular basis in your community of students. So your spheres of influence could be anybody. What you need to start thinking about is not only that I need to making a change to my own behavior about travel, about food, about energy consumption, etc., but could I also influence somebody else to make that change? And that sphere of influence, so the question is, who can you influence to take action on climate change, and how would you influence them? And that's really very important. Now you have got more knowledge, perhaps I'm hoping, compared to what you had 4 weeks ago, right? About climate change. You're more literate about climate change than what you were in week 2, let's say, for example. Okay, how do you pass that on? And it's really important for you to be able to communicate climate change. And how do you do that? It's very important that you adapt your language. So for tomorrow, for example, if you're talking to your friends and family about climate change, it's really important that you speak to them in their own language about what they want to hear. Information on its own won't change minds or behaviors. So you can give them, as I said to you before as well, you can take all the knowledge that you want from these classes, but unless you actually start making those changes in your own lives, it will not make any difference. So action was the most important thing there. Okay. Connect climate change to lives and experiences. And I've always kind of found this very useful and motivational. Think about how has things around you changed over a period of time. Okay. Think about when you were a child and how it is now. How have things changed? Perhaps some of you may have lived in a city which is on the coast. Some of you may have a very strong connection with the forests or trees. Some of you may have lived always in an urban area, and so therefore you might have seen the changes. Population rises, temperature rises. I remember in India when I was growing up, it was always very hot in the summer. The temperature in the summer would be about 42, 43 degrees, very quite regular. Okay, and this is in the central part of India. And this was probably in the 1980s, 90s, which is what I can recall as far back. But now, the average temperatures in my city are about 46, 47 degrees. That's very normal there now. Okay, there are cities in India where the temperatures have actually started to cross 50 degrees. It's actually 52 degrees now. Can you imagine living in a 52 degrees temperature? It's hot. It's very, very hot. You can't go out. It's impossible. People die of heat strokes in many parts of India because of those reasons. Okay, so my experience of climate change, I can, in my own lifetime, I've seen that average temperature rise and how people are suffering because of that. So try and link that to people's own experiences. Um, appeal to people's values. I mean, at the core of it, we all want to do good. Okay, we don't want to harm. We want to do good. So people's values are of honesty, integrity, and supporting the nature and supporting the climate, etc. To appeal to those values, and if you do that, people feel more encouraged and motivated to make a change. And you will see that in your own ways. Acknowledge and explore the value action gaps. So even though we have those values, there is still a gap between those values and those actions. Okay, so it's really important. Be careful with every little helps, because every little might not help. It might actually be a little bit more than every little that we need to do. Be careful with money saving appeals. It might be sometimes that going carbon neutral is slightly more expensive than carry on doing what we're doing. Be careful with scare tactics. Paint a positive vision of the future, so there's always hope. It's not always doom and gloom. And we know that even though we've actually reached 1.1 degrees, we know that we're still far from 1.5 or 2 degrees, and we still have that hope of not going that far. And I'm very hopeful that by 2050 we'll make a huge difference if we all change the way we live at the moment, and the governments change their policies and regulations and everything else. I'm very sure that our global rise in temperature will limit to under 2 degrees by the end of the century, and will start reversing after that in the next century as well. Illustrate with stories and examples, and most importantly, listen to people when you're talking to them about climate change. And I'm very sure that these conversations will happen, whether you like it or not, because we're actually, that is a reality of the world that we live in. And these conversations will come up in your workplace, in your personal lives, and people will have opinions. Okay. And there'll be a time when you'll have to make a decision about, should I take this plane or should I take the train? Should I take the bus? Should I take the car? Should I start cycling more? What should I do? Where should I go for a holiday? What should I eat for dinner? These decisions are actually going to become part of your life. I mean, it becomes natural. When I go to the supermarket now, it's very natural for me to just pick up something and see where it's from. Okay, buying local has become more of a natural thing. It's happened over time. It's taken me about 4 or 5 years to start thinking about this more naturally. Okay, I have made pledges. I've run this carbon literacy training for probably about 5 years now, and I've done this at least about 7 or 8 times already with different groups of people, with staff members in the university, etc. And I've seen that every time I do that, I'm making a new pledge. Okay. The most recent pledge that I made was 80% of my clothes I'll be buying from charity shops now. So 80% of my all my clothing needs are actually now fulfilled from charity shops, or I'm using my clothes for a long time. So if I open my wardrobe, I know that there are clothes which are actually 20 years old or 15 years old. Use things for longer. My phone is now 5 years old. I don't change my phone every 2 years like I used to do before. So things change. as you start thinking about these things. So how do you want to make those changes? I've told my family members not to gift me any new clothes anymore. So that's another change that I've made actually, and they don't always listen to it, but that's something that I've asked them to do, and most people do. My wife always now thinks about twice about what gift she wants to give me. So it's something that you change in your surroundings, and over a period of time. I do not expect that you start change tomorrow, okay? But because now you know, you start thinking about it, and over a period of the next 3-4 years, it might start coming into your reality. But keep it real. That's my main message to you, right? We are moving on to the last part of our lecture today, and this is also the topic of our seminar. So I'm not taking a break. I normally would have done that at this point, but I'm going to be moving straight on so we can finish the next 15-20 minutes or so, and we'll all go home by quarter past or 20 past. I'm hoping not that long. Right. Now we've talked about individual solutions, and we've talked about a group solution, a group that we are close to, like our community or sphere of influence, like I just mentioned. But that's not enough as well. It's important that business leaders, governments, policymakers, industry experts, universities, we all start making big decisions. Okay. And these decisions are about increasing taxes, for example, on fossil fuels, for example, investment in carbon capture technology, investment in more planting more trees, etc., etc., etc. So there is a tool that is created by MIT, Massachusetts Institute of Technology, in Boston, and Sloan Business School, and they call it Climate Interactive Tools for a Thriving Future. And they call that tool, they call them as En-ROADS, Climate Simulation Simulator. We will be using this in our classroom next week. So when you come for your seminars in week number 6, that's next week, please bring your laptops with you, and you'll be working in your small coursework groups in doing that, right? So you can use this simulator for scenario planning, and I'll give you a demonstration about how the simulator works in a moment. What this simulator is telling us, if we carry on doing what we are doing, by 2100, we are set to reach an average global rise in temperature of 3.3 degrees. That's where we are actually heading towards, if we don't change anything. Remember from week 4 seminars, we talked about business as usual and positive future, 2 scenarios. This is business as usual. We are set to rise to 3.3 degrees. However, we have the means to change that. And there are 6 different areas in which we can make a change. How do we use our energy supply? How do we use our transport? How do we make our buildings and industry more efficient? How about population and economic growth? How about carbon dioxide removal from the atmosphere? And how about other sources of greenhouse gases like methane release, etc.? How can we control any of those things and be able to see a change in this 3.3 degrees? So our exercise in the classroom next week in the seminars will be to create our own scenario to bring that temperature down from 3.3 degrees average rise by the end of century to anything below it, even 3.1, 3.2, 3 degrees, 2.7, 2.6, 2.5, ideally 2 degrees, if that's possible. Okay, but we'll see how that might work. I want to show you a little video about how the simulator works. I'll put the link also on GC Learn later on, so you can watch it later on as well. But just have a look at what have they created. I've provided a link below here as well, so you can watch it after.
Hi, I'm Andrew Jones with Climate Interactive, and I'll show you around En-ROADS, the simulator that we built with MIT Sloan's Sustainability Initiative and Ventana Systems. Let's go check it out. En-ROADS is an online simulator that helps people see how actions, say, such as a carbon price.
Oops, sorry.
Hi, I'm Andrew Jones with Climate Interactive, and I'll show you around En-ROADS, the simulator that we built with MIT Sloan's Sustainability Initiative and Ventana Systems. Let's go check it out. En-ROADS is an online simulator that helps people see how actions, say, such as a carbon price, would affect outcomes such as the use of energy, greenhouse gas emissions, and then overall temperature. Seeing if you can come up with actions that limit warming all the way down to well below 2 degrees. Can show a single action, such as a carbon price, or actions together in a combination, adding, say, energy efficiency in transportation or energy efficiency in buildings and industry. You click the buttons at the bottom, and a system dynamics model plays out the equations over time. On the left are global sources of primary energy. The brown is coal. On top of it in red, stacked, is oil and natural gas. In blue, renewables, wind and solar, hydro, bioenergy, and then nuclear on top. On the right are greenhouse gas net emissions from 2000 to 2100. On the right is the resulting temperature increase above pre-industrial temperatures by 2100 in Celsius and in Fahrenheit. Our top 12 graphs, ranging from the drivers of the economy and energy demand, the costs of various supplies of energy, the use of energy, carbon dioxide emissions, greenhouse gas emissions, temperature, and sea level rise as one impact. You can also see over 100 graphs in various areas here in these graphs views. A more advanced user may not want to just set a general carbon price, but could click on the 3 dots and they want to explore a more specific one, say $75, could enter that here. On the right, one can both see the carbon price being set, but also more information under the I button, examples of what the policy means, what the message is, what the dynamics are, the potential co-benefits and equity considerations, the exact settings, and some case studies. One can also click in this corner and see the full user guide with this and the documentation behind many other policies, as well as general information about En-ROADS. One can undo a policy with this back button. One can redo it by pushing the front button. One can also see the changes as a bit of a movie, clicking replay last change, and see it played over 3 times. One can also reset all of the policies and assumptions with this button. And if you've selected several graphs and you want to get back to home, one can hit the home button and get back to the main graphs. Climate Interactive and MIT Sloan built En-ROADS using the best available science with data sources such as here and comparing historical data, sources such as from NASA, from the Met Office, and overall the studies as part of the Intergovernmental Panel on Climate Change, the IPCC. There are many comparisons for history here, such as energy from wind and solar, looking at the past. And in the future, we compare against other scenarios. Climate Interactive tested the model against the suite of large integrated assessment models, or IAMs, from research laboratories around the world. Here is a graph from 2000 to 2100 for greenhouse gas emissions from 3 of those integrated assessment models in an effort that was pulled together by the Network for Greening the Financial System. We input into En-ROADS similar inputs as their models and see what is the output. And now you can see our results relative to theirs. We compare against the others, look for gaps, learn and improve the model, and overall build our confidence in En-ROADS. All the equations in the model are shared in the reference guide that is available here on the En-ROADS website. One can review all of the equations in all of the sectors and all the parameters in the model. And many of the parameters can be changed here in the assumption sector. One can change, for example, the climate sensitivity to a doubling of carbon. Watch the temperature in the top left. It could have been weaker or stronger or weaker. One can change it and also see some of the references behind the analysis shown here. These assumptions are not just in the climate system, but in many other parts of the overall system. En-ROADS is designed to be used in 4 different ways. By yourself or with a small group, you can just create a scenario and share it. In a workshop, the En-ROADS Climate Workshop, with a group of people talking to each other about climate strategy. In a game, the Climate Action Simulation, which is a role play game, or the En-ROADS Student Assignment. Here are some cool advanced climate policies and features in the model not to miss. When looking at the drivers of carbon dioxide emissions, one can view the 4 main drivers of CO2 emissions from energy, the drivers of global population, global growth in GDP per capita, the energy intensity of GDP, of carbon intensity of total final energy, here in this view called Kaya graphs. Here's some advanced graphs not to miss. Here are the top 12, of course. These are the ones that we tend to use the most. One of them here is the stacked greenhouse gas emissions graph that can be very helpful. We also encourage you to go and look at the drivers of air pollution from sources, from energy. It can be interesting when you set a carbon price to go and look. One can also explore the marginal cost of various energy supplies. Watch the green line of wind and solar that's getting so cheap over time. Of course, when it is even more subsidized, it gets even cheaper. Here are some advanced software features. When you make a scenario that you like, say you get this scenario that gets all the way down to below 2 degrees, and you want the world to know that it is possible, one can go to the corner and click Share Your Scenario. It can be shared immediately to Twitter or Facebook, LinkedIn, or by email. You can share it and send it to somebody else with a nice picture about your scenario. Or one can copy the scenario as a URL. When you've made a scenario you like, you can also see a summary here in the Actions and Outcomes view. It lists explicitly all of the policies you just changed, some of the outcomes: temperature, concentration, sea level rise, and cumulative avoided emissions. When you have a question about the behavior of the model, you can go to the support page. There are hundreds of FAQs, frequently asked questions, that are already answered, and one can also ask a specific question by creating what we call a new support ticket to ask a technical question. The simulator shares every month the release notes. That is all of the new things when we update the model with the latest scientific discoveries. Those release notes are shared online. Also, we have translated the simulator into many other languages and are always adding more over time. Overall, the purpose of En-ROADS is to improve decision maker understanding of the dynamics of this overall system as a path to addressing climate and climate-related equity. We hope you can use it to make a big difference in the world. Go get them.
So it's a tool that you can use. It's a tool that's free and something that can continue to use over the next 3 or 4 years, so that by the time you get to your honors year or beyond, you are an expert in using simulation tools to do that. So that's really an important thing. Again, on the En-ROADS Climate Interactive website, you can go and look at courses. They got free courses there that you can actually get, do certifications, and in fact, even better, you can become an ambassador for En-ROADS. So you can actually become a trainer yourself to train other people in those things. So that will be another additional thing in a repertoire of skills that you will have. You will have learned over the course of the next 4 years. Okay. So think about the three things that I've talked to you about. Number one, the certification that you will get from GCU about climate, being a climate literate person. Number two, you can go to those UN websites that I mentioned to you, do the courses and get the certification. And number three, you can go onto the En-ROADS Climate Interactive website, do the courses, and be able to become an ambassador for climate change. We're not finished yet. I'm still going to show you a demo about what to do next week. So just hold on for 5 more minutes. Everybody, calm down. Right? So it's really important that we understand and explore the En-ROADS Climate Interactive simulator. And I'm going to take you there. So this is one of the scenarios that somebody else has created that can actually take us to below 2 degrees or up to 2 degrees by the end of the century. And you can see that they've actually moved the sliders left and right. And that's what we need to do next week. There are two considerations that we have. Number one is, what do we need to do in terms of changing those sliders? But number two, the most important thing is how practical it is. So for example, you might want to tax coal right here, right? So you might want to tax coal, but is that even possible to do that? What will happen if you start taxing coal? Coal will become more expensive. And many countries rely on coal for their energy production, which means that energy in those countries will become more expensive and unaffordable. So you got to start thinking about what is practically possible. Can you really tax coal and oil, which is many countries are reliant on that? Can you tax gas? Can you tax bioenergy? Can you make renewables more subsidized? Can you make nuclear more subsidized? What are the benefits of making nuclear more subsidized? Nuclear is less carbon intensive, so it doesn't really emit carbon at all. So nuclear is really good, but nuclear has got other problems like waste disposal and stuff. Where would you dispose the waste? And that's a big question. At the same time, if you look at other things, you can see that if you start investing money in energy efficient transport, that'll definitely have an impact on the change in the temperature. If you make your infrastructure more electrified, for example, you start relying more on electric cars and electric forms of transport. So you're relying less on oil and gas or diesel and petrol, and that'll have an impact. Similarly, if you make your buildings more energy efficient, if you start using more heat pumps that many buildings are now doing, use triple glazing, let's say, instead of double glazing, would that have an impact? It will definitely, because you're using less energy, less electricity. Electrification, so heating your homes using electricity rather than gas, would that have an impact? Growth, is there any way possible that we ask any countries to slow down their economic growth? No countries will agree to that. You ask any single government from around the world and say, why don't you slow down your growth? They would say, no, we're actually now rising. We want to grow as much as possible so that we can actually increase our GDP, our revenues. Can we ask governments or have any policies that actually slow down the rate of population growth? Yes, possible through family planning activities and stuff like that. But how much of it? That's a question. Can we ask them to slow down that growth? Can we reduce the rate of deforestation? A lot or moderate? Uh, can we actually start capturing our carbon from the atmosphere? Can we start planting more trees? Can we have more technology? So all of these things can be answered. So what we want to do in the next week, you go to that link, you open the Climate Interactive, explore the En-ROADS simulator, and you'll get to that free simulator in front of you. So what it shows you right now is that if we don't change anything, we are set to rise the global temperatures by 3 to 3.3 degrees on average. What we need to do is to start making those changes here. So let's say, for example, these sliders. So let me create a scenario for you. If we start taxing coal, can you see that there is a difference in the temperature? It starts going down. Okay. Can we tax too much? That might not have a positive impact because many countries are reliant on burning coal. So they still have to do that. So let's say if we tax coal a little bit, that helps us to reduce the temperatures. If we tax oil a little bit, not making too much difference, but we can't do too much of it. Natural gas, we probably might be able to do that more, but again, it's not making too much of difference. And bioenergy, tax it more or subsidize it a little bit, not making too much of a difference. How about investing more in renewables, making it easier for people to access, having solar panels, having micro wind energies, windmills on top of their houses? If only if you highly subsidize it, that actually makes a difference to the temperature. You can see now a clear difference between the black line and the blue line. So the black line is the 3.3 degrees rise. That will happen if you don't do anything. But the blue line is what will happen if you start making those changes to the policy. So it's really important for us to understand that we start making changes to the policies, zero carbon technologies. Let's say there is a big breakthrough in technology that we've found that there are vehicles that don't emit anything at all, or we have new carbon capture technology and that sort of thing. If it's a bigger breakthrough, it's not making that much of a difference. So let's say it's a breakthrough. And then we start charging carbon price to countries. So countries have to pay if they emit more or if they use more high emitting sources. So that might look at that difference. Even a little bit makes a difference. So let's say we charge a medium carbon price. And let's come on to the transportation now. For example, if you start making more energy efficient transport, we increase that energy efficiency, make it better. That might have a difference. We start investing in electrification infrastructure, or we start making our energy buildings more energy efficient, highly increased, more electrified rather than reliant on gas. That's quite a possibility because all new houses or most new houses are actually not giving any gas connections anymore. They're all giving electrical connections and they're all based on renewable energy. So that's quite possible. Make it more subsidized, make it easier for people. Population growth, we can't slow it down so much. We definitely should not really increase that because that'll have an impact. So countries can do things to actually limit the growth. Economic growth, it will be best if we actually just leave it as it is. If you increase that growth, which is where we're going right now, the temperatures will start rising. Because more growth, look at the left graph, more growth means more sources of energy that we need. We burn more coal, we burn more oil, and so that's really important. So let's keep it at status quo. Finally, we come to the carbon dioxide removal. Can we start planting more trees? Look at the graph, how that's moving. Okay, but we can't plant a billion trees tomorrow. Emmanuel Macron, the French president, just last week, I think, or this week, earlier this week, launched a campaign that they'll plant a billion trees over a period of time. Most countries or many countries need to do that. Plants are a great source of capturing carbon, but the problem with plants is it takes a long time. If you plant a tree tomorrow, it's not going to start working or taking out carbon particles from the atmosphere straight away. It'll take them 5, 10, 15, 20, 30 years. So even if you plant a billion trees today, it's going to take a long time for them to actually come to a capacity to capture that carbon from the atmosphere. Okay, but we have to start somewhere. We have a technological breakthrough in capturing carbon. We already have the technology, but that's very expensive right now. It will take some time for it to become more uh, kind of more cheaper. The governments have to invest. And finally, the other sources of greenhouse gases. If we reduce the way we eat at the moment, our food behavior, for example, there are two ways of doing that. One is either we reduce the amount of meat that we eat, and number two, we buy locally. So that there is the whole thing about going vegan. I'm not saying that we must all turn vegan by tomorrow. What I'm saying is, if you start thinking about where our food is coming from, if you want to buy local and find out if there are local sources of buying the same things, can you do that? By doing so, we clearly have an impact on the, the methane emissions that we have. And the other thing that we can do is perhaps maybe reduce or recycle so that we are sending less to the landfill. If you send less to the landfill, you're emitting less methane. So that is an easier one. And finally, deforestation. If we reduce the rate of deforestation, that's cutting down trees, that may also have an impact. But doing after all that, we're still coming down to 2.1. I was hoping that we could go down to below 2 degrees. Okay. Now there's another method of doing that. And that's a mad method of doing that. We of course don't want to do that. If I start taxing coal, taxing oil, taxing natural gas, taxing bioenergy, subsidize renewables, clear nuclear, increase net zero, carbon pricing, make all transport efficient, electrified, buildings efficient, highly subsidized, population growth low, economic growth low, more plants, new technology for carbon capture, no methane from landfill and agriculture, and reduce deforestation highly. Yeah, we can achieve that. But is that practically possible? That's not practically possible. So that's not a situation that we want to get into. So the two considerations I want you to think about when you're doing this exercise next week in your seminar is one, what is possible? What can we change? And number two, how practically or politically possible that is. And then you'll answer some questions about it. So that's what I wanted to show you today. Thank you very much. There was another video I had which I can't show you today. Thank you very much, everybody, and I will hopefully see you next week.